Now let's focus on upgrading the kernel on our local system, which happens to be Enterprise 5.0 with a slightly older version of the kernel. Let's confirm the current version by using uname-a, and it's 2.618-8. The new version is slightly newer. So kernel upgrade, and it should be obvious, but the features include provision of updated/patched kernel. Now you can obtain updated kernels from many RPM repositories online, but ideally you should have at least one subscription to Red Hat Network to gain access to the later versions of kernels. In our case, however, we have two releases of Red Hat Enterprise 5. Version 5.0, if we cat the contents of etc red hat-release, we'll see on our local system this is the original release 5. And on the remote system, Serve 4, which is a VMware instance, we've got a slightly newer release. They're both, nonetheless, major version 5. This one's 5.1. On the remote system, uname-a reveals the version. It's also 2.618, but revision 53. So our task is to update the kernel. Use uname-a to reveal current version. Use also RPM query all grep I kernel to reveal installed version. You may also cat the contents of etc grub.conf, which is really a symlink to boot grub.conf to reveal the version of the kernel. Let's try the RPM method. This will come back pretty quickly with the version of the kernel. And there we see it's 2.618.53 on the remote system. Let's copy this query and paste it on the slightly older version, and it'll return 2.618.8. So a lot has changed between -8 and -53 in the way of patches and so on. Also, the 5 system has kernel headers and development packages, so if you want to be able to compile against the kernel, you'll need to install these packages, or recompile the kernel. You'll need kernel headers, and to build new modules, let's say for a network card or USB device, you'll need to install the kernel development package for the new version that we're going to install. Now regarding etc grub.conf, a less of that file, which is really a symlink to boot grub.conf, reveals the version of the Linux kernel that's referenced when the system starts. Grub reads root from hard drive 0,0, the first hard drive first partition. It reads the kernel from that boot partition in a file named vmlinux, and its version 2.618.8. Ditto on the remote system, we can look at the alternate file, boot grub.conf, and you'll see 2.618-53. So part of your typical Red Hat Network subscription would entail the installation of the kernel. The proper way to update your kernel is to install a second version of the kernel, which will not overwrite the existing version of the kernel. So proper installation method is as follows. RPM IVH followed by the name of the kernel package. This will install a separate version of the kernel without overriding the existing version of the kernel, whereas RPM upper U lower VH would overwrite the existing version. By using IVH, you ensure that you don't tamper or overwrite your existing version of the kernel rendering your system potentially unbootable in the event that there's a problem with the new version of the kernel. Now, our version of the kernel is located on the web server. We can download it using, let's say, LFTP and install it manually, or even using yum. So in our local system, let's just navigate into our home directory. We'll make a directory temp. This is where we're going to place the file. Then we'll LFTP. Let's see if it's in our history. And indeed it is. So we'll access history item number 319, which will connect us to the repository. And then we'll navigate into server, and then ls kernel star, which it doesn't find. Because the glob was unaccepted by the FTP, or in this case the HTTP server, via LFTP. So unless we know the full name, for example, here we see ZSH, that is, that's LSL ZSH star, and it doesn't return it. So the web server returns a 404. It doesn't accept the globbing pattern. So let's connect manually. We could have also used a text-based web browser. Then we'll connect to the server into the server subdirectory, where it'll enumerate the packages that are available. And then we'll just Control F with the browser to connect to the kernel packages. Wait for the list to complete, and then Control F. And there we see the kernel package, the latest version. There are other instances as well, such as for PAE, debug, the development package, documentation, and headers. So again, if you intend to provide build support for subsequent modules, you'll also need to install the development package. And if you want to be able to recompile your kernel, you'll need to install the headers package. Perhaps we should just take a note of that. Note, install the following if necessary. A kernel devel star with the appropriate version if module compilation is necessary at some point, and B kernel headers star if recompilation is necessary at some point, of course. May not be for now. Those are optional packages, of course. So the package that's of interest is this full kernel 261853. Let's go ahead and copy its name, and then from the LFTP window we'll get the name explicitly, which it will accept. Here it's about 10.12 megabytes, and since RPM packages are compressed, you can expect it to occupy more than 10 megabytes on your hard drive. So let's exit. Now in our temp directory we've got the kernel package. So the next step is RPM IVH. This will create a grub entry as well as install the new version of the kernel. So RPM IVH followed by the name of the kernel. And we'll just note this will update grub via boot grub.conf, and will also place the new kernel in the boot file system. We'll also place the new kernel in the /boot file system. Let's give this a try from the shell using RPM IVH. And there we see it's installing with no trouble whatsoever. But once completed, we need to examine the traces left on the system again. In /boot as well as /boot/grub/grub.conf. This takes a little while. Needs to make the modifications. And then all that's left once we've confirmed that the items are where they're supposed to be is to reboot the system and default to the new version of the kernel and ensure that it works. This should be wrapping up, and now it's done. So again, now let's RPM query all grep kernel to see what's installed in our RPM database. Notice the original version 2.6.18.8 or -8, as well as the new version 2.6.18-53. We'll refrain from installing the headers and development packages until we have confirmed that the new version of the kernel boots our system with no trouble whatsoever. Now let's examine the items that we've mentioned. So the last step, of course, is to examine traces in the following places: /boot, as well as /boot, grub.conf. These are the key places. So with that said, let's navigate to boot and lsltr, where we still see the symbolic links, the soft links to the Perl scripts, but more importantly we see the old VM Linux kernel as well as the new VM Linux kernel for 2.6.18-53. Also notice that there is a new initRD entry for the new version of the kernel. This is all installed by default by the installation of the kernel package. This initRD matches the new kernel 2.6.18.53, whereas the older initRD 2.6.18.8 matches the older kernel. Also note, let's navigate into grub, that the menu.list file, which is a symlink to grub.conf, has been updated, and there is a new menu entry for the 2.6.18.53 kernel. Also note that the default kernel is 0, which indicates that when the system's rebooted, it will default to booting with the 2.6.18.53 kernel. So by executing rpm-ivh, the initial RAM disk image is created, the grub entries are updated, a new kernel is placed in /boot, and all that's really left for you to do is reboot the system. We see the entries mimic what was there before. The root files, or the boot file system, but root as far as grub is concerned, can be found on the first disk, first partition. The updated kernel can be found beneath that partition as VM Linux 2.6.18.53. The root file system, it knows to find it on the vol group 00 logical volume 00. That's how the system was set up. And the initial RAM disk is 53. But if for some reason there's a problem booting the system, you have 5 seconds, timeout equals 5, to interrogate or interrupt the grub startup process and select the second kernel or modify the first or second kernel. In all likelihood, the second and older kernel will always be able to boot the system. And also in all likelihood, the new kernel, since it's slightly different, will be able to boot your system, since the initRD and the kernel has been placed into the proper location. But again, it's good to eyeball the items just to make sure that they indeed exist where they're supposed to beneath the boot file system, which is the root file system as far as grub is concerned. Once grub hands over control and the initial RAM disk is set up, the appropriate drivers are loaded to access the remainder of the file systems, including the root file system. Also note that a config file for 2.6.18.53 has been created, which includes the options that have been enabled and disabled for the compilation of this kernel binary, and a system map file has been created. So all of the items that we saw with the older version have been created for the new version, including symvers. Every file exists just like the older version. So this is one way to effectively update our 5.0 system to the kernel that runs on 5.1. Just use rpm-ivh. Now at this stage we simply need to reboot and confirm, once the system's up and running using uname-a, that indeed this has worked as we have expected it to. So with that said, let's save our documentation and close out. We'll close out the browser as well as the Nautilus window, and we can either system, log out, and once at the main menu restart, or execute reboot, or init 6, which will reboot us in default to the 53 version of the kernel. So let's go ahead and kick this off. Now we've rebooted our system. Let's open a shell, reopen our applications, and confirm the current version of the kernel to be 2618.53. So it's booted as expected. Let's launch gedit, sending it to the background, and reopen our notes and continue our studies. So reboot has proven successful in this stage. The next step is to remove traces of the older kernel since it's no longer necessary. Let's scroll up and just check our steps. So we'll list it as step 3. Remove traces of former kernel. Very straightforward as well. You can RPM E or -E the appropriate packages, including the kernel, the headers, and development packages. Let's RPM, in fact we need a root shell, so let's SU in. Then RPM query all grep I kernel, although it's all lowercase. But just to be on the safe side, we need to remove 18.8, any traces of 18.8. So this is one package, as well as headers and development. And we left off the suffix .el5 to make it distinct. Let's copy the name. This removes the old version, or older version. We also need to get rid of headers and the development packages, and once they've been removed, install the appropriate headers and development packages for the current version of the kernel. Let's go through the list again to be sure that the older version has been removed. And so far so good. Let's remove the headers package. In this case we need to be explicit with the name of the kernel, as the new version shares most of the name of the older version. RPM E, and you can indicate, by the way, multiple packages to remove, or to the remove option, the E option. This will get rid of the development. And here it throws a dependency issue, which we could force using the no dependencies, or to ignore the dependencies with removal. So since headers is giving a problem, let's first remove the development package. And then that'll leave us with having to clean up the headers package. So let's just make a note of that. Remove, or force remove, ignoring dependencies. Let's see the current state of affairs. Looks pretty good with RPM query all grep kernel, which should return the current version plus the older version's headers package, which we need to remove using RPM. So in this case we'll rerun RPM E with the no deps option for the package, for the headers package that is. We've removed the development package. And let's just indicate that ignoring dependencies using no deps. So the full command, of course, will be RPM-E no deps kernel headers. So remove traces of former kernel using RPM-E with optional no deps option. Let's see where we stand. And this looks pretty clean. We'll echo the exit status to make sure, and it looks good. That's RPM query all, and we should be left with the new version of the kernel with no development or header packages. Now, as far as installing those additional packages, we could use yum, since it is configured, to install the headers package as follows: yum install, and if we want it to not prompt us, just indicate yes, kernel headers, and have it search for the kernel headers from the repository that's located on the web server. This will search for the package. There it is, kernel headers 2.6, and install it for us. So let's just list as our fourth task, install new headers and kernel devel packages using a program that we've studied, yum. So yum-y install kernel-headers, just put in what you know of the name of the package, and yum will take care of matching what you've inserted with regular expressions matching, followed by yum-y, and we could have, again, installed both of these simultaneously. Install kernel devel, and that should suffice. Let's take this line as it is the next item to run and see where we stand. So this has completed. We'll RPM query all again just to be sure that the headers package has been installed for the 53 patched version of the kernel, which we should see momentarily. And there it is. Now let's get the development package. And it's going to search the repository. It will find the package. It's the only package. It's 4.7 megabytes. And we'll echo the exit status at the end of the process to be sure again that it has executed to our expectation, again returning a zero exit status. Any non-zero exit status, of course, would be cause for concern. So this has been installed. We'll get the complete message momentarily. There it is. We'll echo. Then one last RPM query all to grep kernel, and we should see the results, which includes, of course, the package itself, the development, and headers package. Super. So this is fine. And we'll just list as a fifth step, confirm that the 3 kernel packages are installed using RPM query all grep kernel. This should return the 3 packages. And with that said, we've successfully upgraded our kernel to the 53 patch version. Again, a uname-a will return as such. Now, by virtue of removing the older version of the kernel, the reverse has occurred with respect to the grub configuration and /boot directories. Let's just note that. Note, removal of older kernel packages cleans up A /boot, B /boot grub.conf, which is also symlinked to menu.list. Well, let's confirm as such. We'll navigate to boot, which is the root file system as far as grub is concerned when the system boots. Notice we only see entries for the 53 version, no more -18 version. For initRD, sim versions, config, system map, and the VM Linux kernel itself. Let's navigate into grub. We'll list the contents of grub.conf, which is symlinked to a name menu list, and notice that's it. The entries have been removed. So the RPM process nicely cleans up for us. So now our lone entry will be the 50, or is the 53 entry. Well, we've confirmed that it's properly booted the system. Again, if you're pursuing certification, RHCT, RHCE, and you need to update the kernel, these are the steps you'd take. Just to recap, you'll need to install the new version of the kernel using IVH. Once it's installed, confirm the traces in /boot and /boot/grub/grub.conf. Be sure that the menu items are there, or the menu entry is there. There should be 2 items. Once you've rebooted the system, remove the older version of the kernel and associated packages, including kernel 2.6 and its version, headers and a matching version, devel and the matching version. Once that's proceeded properly, install the new kernel headers and kernel development packages. Then confirm the boot environment, ensure that traces have been removed. And that's it. You're done. The kernel is up to date. We have the latest patched version in the event that there were security issues related to the 2.6.18.8 version that was included with the original Red Hat Enterprise 5. So it's really not terribly difficult to update the kernel. It's straightforward. It's much easier than it has been for other distributions. So as a consequence, it's not as terrifying as the process once was which was riddled with errors, and if you did it remotely, chances are your system didn't reboot properly, and if you had no access, you may perhaps have had to have visited your data center or system location to rectify the problem. Nowadays it's straightforward. The old version's preserved and you should be able to get into it, but it's still no excuse for not having an out-of-band means of communicating with your system, such as a plug-in card in the server, like a DRAC card with Dell servers, or a serial concentrator which connects you to a serial port, or some other means of connecting to the system in the event that the update process fails across the wire. Generally, this is the sort of process you want to do or perform in person, but isn't always feasible. If you can, however, do it in person, up close with the server, and that will save you a lot of time in the event that the process is broken or fails for some other reason. So with that said, let's move on to some other items you need to know about with Red Hat Enterprise Linux.